Example C wants us to graph the conic section 16x squared minus 9y squared minus 96x plus 288 is equal to 0. Now, I'm going to rewrite this so that the x terms are next to each other. So I've gone ahead and I've placed the x terms next to each other and put them inside a set of parentheses. Now, our life would be a lot easier if 96 was divisible by 16. So let's see if it is. Oh, it is. Wonderful. And the reason that is because that means that both of these values or terms here are divisible by 16, and we could factor out a 16. So if we do that, we're left with 16 times the quantity x squared minus 6x, and then the rest of the equation will remain unchanged. Now, we want to go through that same process that we did in the previous example where we completed the square. So we want to take this value, we want to divide it by 2, and then we want to square it. So negative 6 divided by 2 is negative 3. If I square that, that gives me 9. So here I want to add 9. Now, you might be inclined to say, well, if we're adding 9 there, then we need to subtract 9 here. But what's actually happening is we're really adding 16 times 9. And so I need to account for that 16 on the outside of the parentheses. 16 times 9 is 144. So I really need to subtract 144 here. Now let's do some algebraic simplification. So I'm going to have 16 times, I can factor the thing inside of the parentheses to be x minus 3 quantity squared minus 9y squared plus 288 minus 144 is 144, and that is equal to 0. Now what I want to do is I want to subtract 144 from both sides, and that will give me with 16 times x minus 3 squared minus 9y squared is equal to negative 144. Now, this looks like my intuition tells me that this is going to be a hyperbola because there's a minus sign here, but we could be wrong. Let's go ahead and do some more algebra to see what's going to end up happening. But my intuition is telling me that this is probably going to be a hyperbola since we have a minus sign, whereas ellipses will have a plus sign. So I need the right-hand side of the equation to be equal to 1. So I'm going to divide both sides of the equation by negative 144. Now, if I do that, the right-hand side of the equation will equal 1, and then I'll have negative 16 times x minus 3 squared over 144 plus 9y squared over 144. So I need to see 144 divided by 9 is 16, and 144 divided by 16 is going to give us 9. So that is going to look like negative x minus 3 squared over 9 plus y squared over 16 equals 1. And I'm going to rewrite the order so that there's a subtraction sign. So we have y squared over 16 minus x minus 3 squared over 9 is equal to 1. So this is in fact a hyperbola, and it's not centered at the origin. So we have to think about where the center is. And remember that when we're graphing a hyperbola, we want to create our central box. Okay, so If it's helpful for you, you can think of the y squared as y minus 0 squared to help you figure out h and k. So the center of our central box is going to be located at 3, 0. The 3 is coming from here, and the 0 is coming from there. Okay, so my center of the box would be right here, and then we need to figure out what the dimensions of the box are, like how much we're going up, down, left, and right. And that's going to be dictated by our A and B value. So we know that our A squared is this thing here. So A squared is equal to 16, which is going to imply that A is equal to 4. And here B squared is equal to 9, which tells us that B is equal to 3. And so since our A value is 4, that means that we're going to go up 4 from the center and down 4 from the center, and then we'll go right 3 from the center and left 3, and now we can create our box. And we can draw our asymptotes by connecting the opposite corners of our rectangle. So I'll just kind of highlight the ordered pairs there and then connect them with my ruler here. Okay, so just gotta love technology. So we want to make sure it goes through the center of the box as well as both of the corners. And then I'm going to highlight the other 2 corners and connect those. Okay, drawing this asymptote was a little bit easier and was giving me less trouble. Okay, and then we know that my one vertex is here and my other vertex is here, and we're going to draw it so that it hugs the slant asymptotes. And it's going to look something like that. So that should really be the only portion of our graph that's used a solid curve instead of a dashed curve. And it doesn't ask for this, but if it did, if we wanted to locate the foci, we would need to calculate C by using the equation. I'm kind of running out of space. I'll do it over here. C squared is equal to A squared plus B squared. Please notice that the way that you find the foci is different whether you are doing a hyperbola versus an ellipse. Those require different equations. So for a hyperbola, it's C squared equals A squared plus B squared. If this was an ellipse, the formula would be C squared equals A squared minus B squared. So please do notice that the equations are different to find the foci. So now we get C squared is equal to 16 plus 9, and we get C squared is equal to 25. And then if we take the square root of both sides, we get C is equal to 5. That tells me that from the center of my box, I want to move up 5 units, 1, 2, 3, 4, 5. So one of my foci is right there. In fact, let me use a different color so that it's clearer. And then my other foci, or my other focus, I'm going to start at the center and move down 5 units. So these 2 ordered pairs here represent my foci. And those are located at 3, -5 and 3, 5. Those are the location of my foci. And that concludes this example of graphing this hyperbola.